Hi everyone, I really hope you're okay, and I hope the videos we keep uploading are helping you out. If you are new to the channel, guys, please don't forget to subscribe. If and if this is the first video you come across, please note that there are 5 videos before this one whereby I answer the first 5 questions from the November 2023 Physical Sciences paper 1. You can download the paper, answer the questions with me, um, and if there are misunderstandings, guys, please don't be shy rather to write on the comment section. I'll definitely come back to you. Okay, we are told that an ambulance is moving away from a stationary listener with a constant velocity of 25 meters per second. The siren of the ambulance emits sound waves at a frequency of 550 Hz. However, the listener detects the frequency of these sound waves to be 512.64 Hz. Okay, basically they are telling us that the frequency of the source is 550 Hz, right? And then the frequency of the listener is 512.64 Hz. The velocity of the source is 25 meters per second, moving away from the from the listener. And then the velocity of the listener is simply 0 meters per second. Why am I saying that? Because we were told that the source is moving away from a stationary listener. All right, together. The only thing we don't know is the speed of sound in air. That's what you don't know, né? Okay. And then we are told to ignore the effects of the wind. The first question we are supposed to state Doppler effects in words. Doppler effect is simply an apparent change in the observed frequency as a result of the relative motion between the source and the listener. Okay, and then 6.1.2, we are supposed to use the given information to calculate the speed of sound in air. We are going to use our Doppler effect equation for us to find the speed of sound in air. This is V plus or minus VL all over V plus or minus Vs multiplied by the frequency of the source, right? Okay, the V represents the velocity, the velocity or speed of sound in air. Are you together? So V is what you are looking for in this case. Are you together? Since my velocity of a listener is 0, I was supposed to say minus 0 here. Are you together? But why am I choosing minus? Remember that, guys, whenever FL V, it's plus or minus VL rather, then plus or minus VL multiplied by the frequency of the source. Né? If and only if the source is moving away from the listener, please note that there at the top you put a minus, and then at the bottom you will choose a plus. All together. But if the source was moving towards the listener, it was going to be a plus here. It was going to be a plus there, and then minus at the top. No, minus at the denominator. Are you together? So this is how you know which sign to pick. So in this case, I know that my listener is stationary, so I don't need to write minus 0. I'll just leave it as V all over V plus Vs multiplied by the frequency of the source. Are you together? I do know the frequency of the listener. that's 512.64. I'm looking for V. I know I have V here, all plus 25, and I have 550 over there. All I need to do here, guys, is to just cross multiply, right? So I'll simply have 512.64 multiplied by V plus 28 is equal to V multiplied by 550. That's 550 V. And then I'll have 512.64 V plus 512.64 multiplied by 25. Why did I write 28 there? The speed is 25, not 28. I can't even see my bad handwriting. I'll simply get 12,816 is equal to 550 V. I'll have 550 minus 512.64. I'll be left with 12,816 on the left hand side. Then on the right hand side I'll have 37.36 V. Are you together? Then for me to find V, I need to divide by 37.36 both sides. Therefore, the speed of sound in air is simply 12,816 divided by 37.36. That's 343.04 meters per second. This is the speed of sound in the medium. Now I've calculated the speed of sound, right? The speed is 343.04 meters per second. Okay, and then now you're told that if the ambulance moves away from the stationary listener with a constant velocity which is greater than 25 meters per second, how will each of the following change? Choose increase, decrease, remain the same. Okay, the speed of sound in air will remain the same because it is never influenced by the velocity of a source. Are we together? So the speed of sound in air will just remain the same. And then the frequency of the sound waves emitted by the siren. The frequency, the pitch of the siren will never be affected by how fast the ambulance is moving. It will just stay the same. Are we together? So here, number one, it's remain the same. Number two as well is remain the same. And then see the frequency of the sound waves detected by the listener. The frequency of the sound wave detected by the listener. Since the velocity of the source will be higher, it simply means that the source will be moving faster away from the listener. All together. So that simply means that the listener will detect a lower frequency. So here we'll simply write decrease. Okay, and then we are told that the spectrum of a distant star when viewed from the Earth is redshifted. 6.2.1 is the star moving away from or towards the Earth or towards the Earth. It's moving away. Why am I saying that? Because they said the star is being redshifted, right? So it simply means that the star is on the far end of the red spectral line of the red spectrum. Together, remember that we have our it's Roy Bev. Are you together? So if you move towards red, it simply means that you have a lower frequency. Are you together? But if you move towards violet, you'll have a higher frequency. Are you together? So that's why I'm saying this thing simply means that the star is moving away from the earth because it is being red shifted. Are you together? And another thing you need to know is that the red color has the lowest frequency and the largest wavelength compared to other colors. Are you together? Yeah, so that's how you could have answered the Doppler effect equation, guys. Please, guys, if you like the content, press the like club, and please share as much as you can, just to help us to reach as many learners before they write shame. Bye bye.